Before we move on to example 4, I want to make the note that whenever you want to find cumulative effect over a varying rate of change, you can integrate. What this means is that if you ever want to figure out how much something has changed over time, or how far distance or how fast speed has changed, or how much something has changed or accumulated, the typical way to solve that kind of problem is integration. In example 4, we'll see a different type of example of how integration can be used in an application. So example 4. Over 5 years, the rate of potato consumption was modeled by the formula C of t equals 2.2 plus 1.1 to the t million bushels per year. How many bushels were consumed between the second and fourth year? So what I want to point out at this problem is that we have our equation right here. And we want to know between the second and the fourth year. So simply, this just becomes the integral from 2 to 4 of 2.2 plus 1.1 t dt. And then all you have to do from here now is go ahead and put this in a calculator. And by putting this in a calculator, you'll end up getting your answer as 7.066 million bushels between the second and the fourth year. However, I want to go over also what you do if you cannot put it in a calculator. So if not, we can, and this is something we can integrate by hand. So the integral of 2.2 is going to be 2.2t plus 1.1t divided by ln of 1.1 from the interval 2 to 4. So then all you have to do is put that into a calculator. You can use a scientific at this point. And it'd be 2.2 times 4 plus 1.1 to the fourth over ln of 1.1 minus 2.2 times 2 plus 1.1 to the squared divided by ln, just this part divided by ln of 1.1. And then on a free response, that would be an acceptable answer, and if you put that all into a calculator, you do get 7.066 million bushels. Right now on your own, I want you to try the problem that's on page 386, number 21. This problem talks about oil consumption, and it says that the rate of consumption of oil in the United States during the 1980s is modeled by this function, where t is the number of years after January 1st, 1980. So it's important to note that t equals 0 is 1980. Find the total consumption of the oil from January 1st, 1980, so t equals 0, to January 1st, 1990, and this is 10 years later, so this is t equals 10. So on your own right now, try that out. Alright, let's see what we got. So we're going to take the integral from 0 to 10, and our formula was 27.08 e to the t over 25 dt. So this becomes 27.08 times the integral from 0 to 10 e t over 25 dt. And we're going to need a u sub. So we're going to let u equal t over 25. So u is equal to 1 over 25 times t. So du is equal to 1 over 25 dt. So 25 du is equal to dt. And if t is equal to 0, then u is equal to 0. And if t is equal to 10, then u is equal to 10 over 25, which is 2/5. So our new integral becomes 27.08 times 25 times the integral from 0 to 2/5 of e to the u du. And then from here, you get 27 times 0.08 times 25 times e to the u from 0 to 2/5. So this is 27.08 times 25 times e to the 2/5 minus e to the 0. And if you put that in a calculator, you get about 332.965 barrels. This is more if you did not have a graphing calculator for a no calculator portion. If you did, you would simply just use the integral in the very beginning.